Beth.
And I'm Beth.
Welcome to Physics with
Beth and Beth.
Hi, welcome to Physics with Beth and Beth. We're still on that AP Physics 1 curriculum, as we will until we finish Unit 8. I know this is Unit 6, but I realized that there was one problem in Unit 4, back in our momentum and impulse and collision unit, that I had not gone over, and I wanted to go back and address that. All right, because it is pretty important, and it's a nice little trick that you can use only for elastic. This will only work for elastic collision. Do not try this little equation for inelastic. Only if the problem specifically says it's an elastic collision can you do this. All right, well, what we've been used to in inelastic collisions, they give you a couple of things that are interacting. They're going to have a collision. In this case, this 25 kilogram car is overtaking this little 10 kilograms. So I've got some carts, some little toy carts or something, or physics carts, overtaking this 10 kilogram cart that's going 15 meters per second. And afterwards, normally in an inelastic collision, if they are both moving separate and it's not a hit and stick, then they will give you one of these final velocities, and then you just have to solve the other one, and you do that with conservation of momentum. All right, where momentum before equals momentum final. But in an elastic collision, you might get a problem where they don't give you either velocity. And you're like, okay, but if I do my momentum before equals my momentum final, and I'm going to call this cart 1, and I'm calling this cart 2. I would have M1 V1 initial plus M2 V2 initial equals M1 V1 final plus M2 V2 final. And, if it had been inelastic and they had given us one of these velocities, then we would only have one variable. But when they do an elastic and they ask for both, it's like, whoa, wait a minute. I know masses, I know initial velocities, I know masses, but I have two variables I don't know, and how do I solve that? Okay, well, elastic collisions conserve, let's remind ourselves that momentum before is conserved. Momentum before equals momentum final, meaning momentum is conserved. Kinetic energy before equals kinetic energy final, meaning that kinetic energy is conserved too, only in elastic collisions. All right, so you could use the kinetic energy piece, but it's going to get really ugly mathematically. You're going to get a quadratic. You're going to have to solve, and it gets really ugly. So if you don't have either, put it that way, if you don't have either, if you have one, then of course you could do that, and it would be easy to do mathematically. But when you have two variables you don't know, you're going to end up in a pretty tricky little place if you go to kinetic. So here's another equation for elastic only. I'm going to emphasize that. Elastic only. You can say that the initial velocity of cart 1 plus the final velocity of cart 1 has to equal the velocity initial of cart 2 plus the final velocity of cart 2. Because their masses don't change in this. So if kinetic energy before equals kinetic energy final, then that means this cart's initial and final velocity has to equal this cart's initial velocity and final velocity. Okay, add it up. Perfect, because their masses are going to stay the same, both sides. Perfect. So we're going to use this equation, and I'm going to solve for this cart 2, its final velocity. So I know that my initial was 20. I know my initial, final. Let me keep that there. I know my initial for cart 2 was 15 plus this V2 final. And I'm going to solve for that V2 final, meaning the second cart's, the 10 kilogram cart's final velocity. So all I did, I know my initial cart for 25 kilograms. That cart 1 was 20 meters per second, was its initial velocity, V naught for cart 1. All right, I don't know my final. It's one of the things I don't know. On cart 1, I know my initial here was 15 meters per second for cart 2. And for cart 2, I don't know its final velocity either. I'm going to now solve for this little expression, this little second velocity here for cart 2. and final velocity. Ooh, words are so hard today. I'm going to solve for the final velocity of cart 2. So I'm going to subtract 15, so I get 5 plus the initial, cart 1 final velocity equals cart 2 final velocity. Wow, I don't know why I'm having so much trouble with that. Okay, so now what can I do with this? I can actually take this little expression and plug it in here for that cart 2's final velocity. And now I will be to only one variable that I can solve. So I'm using this beautiful little equation we have here to give me an expression for that second cart's final velocity, and I can plug it in here and I'll be down to one variable. We love that. I'm just going to go ahead and start plugging and chugging here. Probably should come up with an expression first, but just to save us a little time, I know my mass 1 is 25 on that cart 1. I know its initial velocity was 20. I know on cart 2 it had a 10 kilogram and its initial was 15. I know my mass again on that first cart was 25. We're looking for that final velocity of cart 1. In mass 2, it was 10 kilograms. And now I'm going to put in this expression, 5 plus that final velocity on cart 1. All right, all of this, that comes out to be, that's 150. Well, let's just keep this out. We're going to do 25 times 20 plus 10 times 15 equals 25 v cart 1 final velocity plus 50 plus 10 final velocity of cart 1 again. So I only have one variable here. Voila! If you solve that, subtract 50 over, I believe that's going to give you 600 equals 35 v1 final, and that means your final velocity on cart 1 is going to be 17.1 meters per second. All right, but they asked for both velocities, so what do I do with that? Well, go plug it back into this formula that we have. We said, hey, V2 final is equal to 5 plus V1 final. So that's going to be 5 plus 17.1. And that means your V2, that's velocity on cart 2 final, is going to be 22.1 meters per second. And that is how you do this. You can only use this equation if you have elastic. Now, if you pull up things like AI, for instance, and you ask it a question about what's another equation for elastic to find the velocities, it's going to give you this huge, massive thing that it has derived. All right, and it'll work. It's right. And some teachers use that, and that's great. If your teacher uses that, that's great. It will work. You'll get the right answer, and it's going to be this huge multiple expressions. That is really hard to memorize for the AP exam. It's also really hard to derive quickly when time is never your friend on a physics exam. So if you go with this little easy peasy thing, then you can always come up with an expression for 1. It wouldn't have mattered. I could have come up with an expression for my initial final velocity and said that -5 plus, if I wanted to solve for this, it would be -5 plus your second cart's final velocity. It's okay. It wouldn't have mattered, and you would have plugged that in here. All right, it doesn't matter if you solve for the cart 1 or the cart 2 final velocity, but solve for one of them and then plug it in the equation where it goes. All right, and then easy peasy, you get your answer, and it's way easier than memorizing that huge expression that you'll see if you try to pull this up on Google. All right, perfect. Hope this helps. If you like this video, give us a thumbs up, and thank you for watching, and happy physicsing.